Alright, let's go through the Chapter 2 test. Determine what one change in the definition, this definition, of f of x that would make f of x not be a function. Right now it is a function because 5 is from the domain is mapped to 5 of the range. Negative 3 is mapped to a 2. 7 is mapped to a 3. And 1 is mapped to a 2. So we have no domain element going to two different range elements. There's no two timing going on, as I said in class. To make this not be a function, all you have to do is either add a point where maybe 5 was going to something else, or negative 3 was going to something besides a 2, or 7 is something besides a 3, or 1 to something besides a 2, or change one of these to be a 5, or to one of these be a duplicate, so they're going to 2. So I'll just do this one. I'll say f of x, change it so that we leave it 5, 5 in there, and I'll just change this negative 3 to a 5, 2, and now I would have 5 going to there. I've dropped the negative 3, and 7, 3, and 1, 2, and that one change would cause it to be not a function. And so it says to explain, so I say now 5 of the domain is mapped to two different range elements. Okay. All right, number 2. If the following is not a function, give evidence that demonstrates why it is not otherwise stated is a function. Well, to be a function, it has to pass the vertical line test. The vertical line can't hit the function more than once. And right at negative 1, at x equal negative 1, the vertical line test intersects the function twice at negative 1, 2 and negative 1, negative 1. So this is not a function. Okay? And then 3, domain. So the domain of the first one, well, we have no square roots, but we have division, and the denominator can't be equal to 0. So if I subtract 3 from both sides, I get 2x equals negative 3. Divide by 2, and x cannot equal negative 3 halves. So the domain would be all reals except negative 3 halves. Written in set notation, set whose elements are numbers such that the numbers are not equal to negative 3 halves. Written in interval notation, you don't have to do all 3, you only have to do one of these, but I'm doing all 3. So if it can't be this, it can be anything below that, from the smallest, negative infinity, up to negative 3 halves, or above negative 3 halves, negative 3 halves to infinity. Okay. B, f of x in this one. So what's the domain? That's the x values. That's these. So the 5, the negative 3, the 7, and the 1. So I can only list those. So 5, negative 3, 7, and 1. I can't use interval notation, parentheses, because the numbers in between are not included. And I can't say from negative 3 to 7, because those would include the numbers in between. Only those, and so I can only list the 4 domain elements that are there. Okay? And then C, I have a square root, and the square root can't be of a negative. The stuff inside, the 4 minus 2x, has to be at least 0 or greater than 0. So if I subtract 4 from both sides, I get negative 2x equals greater than negative 4. Subtracting negatives from both sides doesn't do anything. Divide both sides by negative 2, and that does flip the sign. And so I can say the domain is all reals less than or equal to 2, or I could say it in interval or set notation, set whose elements are numbers such that those numbers are less than or equal to 2. Or I can do it in interval notation. That means from negative infinity is the side that's less than, up to 2 including the 2. Square bracket means including. That's page 1.